Okie dokie, here we have my 15 volt at 30 amp power supply, and I've made a few modifications to it. So let's see what kind of modifications I've done. Well, I have made the fan that is controlled by a thermostat run permanently. And the main reason why is because the power supply was starting to run a little bit warm over a long period of time, which is normal, but I wanted to make sure that the unit stayed cold all the time to prevent it from overheating. So this is what I did. Now I can't take the cover off because unfortunately I haven't got any screwdrivers at this moment in time, but down here, just there, pointing out here, you can't see it very well, but there is a thermostat, and now that's been bypassed, aka disconnected. And what happened was, the cables that came out of that ran down to a little circuit board that had like a little IGBT/MOSFET type resistor thing on there, and that also acted as a controller. So this is what actually happened when it engages. Now if you're wondering what the noise is in the background, it's just an old computer doing some tasks. Well, what happened was the secondary side of the transformer, a few cables went to a capacitor bank, and there's two capacitors soldered in series. The top one was a 22,000 microfarad capacitor, and the one below was a 27,000 microfarad capacitor, and they were both at 35 volts. Now that's a lot of capacitance, 49,000 microfarad of capacitance. Now that's quite strong, and what you got to remember is capacitors hold charge, and I forgot about that. I stripped live and neutral with no problem, it didn't spark. As soon as they touched, it sparked and made a little bit of a bang. So I thought, oh dear, as soon as I power it up, it's going to be a problem. But it didn't. I went a little bit off track. So what happens is there's a red and a black, live and neutral, comes out into the board. Then you've got your two wires coming from the thermostat onto the board, and obviously your two wires coming off the fan to the board. As soon as that engages, power comes through, turns the fan on. Now, what I've done is I've cut the wires from the thermostat and just put a little bit of tape over the two wires and kept them separated and just put them somewhere where they won't get in the way. And I got two small blue crimps and just stripped the live and neutral wire cable coming off the capacitor bank and stripped the live and neutral coming off the fan and connected live to live, neutral to neutral, or red to red, black to black. And now it works. I had high doubts for some reason when I was going to power the thing up, so I put hearing defenders on just in case those capacitors were to reduce the stress on the transformer. But I was wrong. I was fearing for the worst, that the fan would go bang and there would be a fire, and that would in end kill the power supply. Now the fan in this is a Sunon 80mm 12 volts DC at 3.1 watts. Now this thing's quite strong. Now what I shall do is I'll show you what I mean by it pulses. Now what I've got a feeling is that the capacitors are filling up with power and then draining quickly because this thing pulls a lot of watts. So that could be the main reason, or that little IGBT/MOSFET was a controller or rectifier and keeping the fan from pulsing. But it's a bit too late now. It's been bypassed and I don't really want to... Well, I should have really just put the live and neutral, the two wires together on from the thermostat, and that would have engaged it. But what can I do, eh? It's too late now. So there is the fan, and it's quite strong, like quite powerful, but it gets hot kind of reasonably fast. Well, 10 minutes continuous use, it gets a little warm. Well, I'm not sure if there's too many volts going through this, because it seems to run a little bit too fast. Let me demonstrate. And I'll show you one more time. Now the main reason why you can tell it's on a capacitor bank is because this fan would stop a lot faster than it is now, and the capacitors take a long time to drain out, hence why that fan takes a long time to stop. Okay, I thought I'd demonstrate what I mean by the fan pulses. Before I had someone else in. But other than that, I'm really pleased with the output, to be honest. This side here is a little bit dull, but the airflow travels from one side to the other, so that's understandable. I thought I'd show you, kind of, if I can, the output of this thing by using something. Just give us a minute. Okay, I thought I'd show the output. This is a vent here. The camera's light's not the greatest thing in the world, but it does shine some light. There's a grill. And I thought I'd show the output by using a water bottle lid label. The output is quite impressive. I'll show you that again. So yeah, I'm quite impressed with this. But I still don't know why it's pulsing. I think that my gut feeling might be right, but I'm not 100% sure. So there we have it. Thanks for watching, and we'll see you on the next one.